Swayam Prabha. Digital India. Educated India.
Okay. So, we have been discussing about heterogeneous, because I would like to give a flavor for heterogeneous reactions. So, that means what extra information what we require for heterogeneous reactions. Abdul, what extra information? Mass transfer step. But we have taken only isothermal reactions, and if I have non isothermal reactions, it is not only mass transfer, even heat transfer will come into picture. Why? Because in the bulk you have a different temperature. On the particle, if it is a catalytic reaction, you have another temperature, right? Or in exothermic reaction or endothermic reaction. Endothermic reaction, the temperature of the particle will be less than the temperature in the bulk. If it is exothermic reaction, the temperature in the bulk is less than bulk. I changed the argument. So, in the bulk it is less, and at the particle exothermic reaction. So, you have more temperature. So, there is a temperature gradient also between the film and the actual particle, right. So, that heat transfer also you have to take into account, right. So, that we will do in the next semester, but first things, simple things what we want to understand. We have derived an equation for catalytic reaction, right. Catalytic reaction, and you got a rate minus R A equal to CAB by minus divided by 1 by kg and 1 by k, and we also know that now in under some conditions k, that is reaction rate constant, will not come into picture for design at all. It will come only, the mass transfer coefficient, that will come into picture. That means, my rate equation now contains only mass transfer rate, mass transfer coefficient, rather than chemical concentration and also chemical reaction rate constant. You see, and that happens most of the time for combustion reactions. Why?
High temperature and
all combustion reactions are at very high temperature, 600, 700, 800 like that. So, the reaction rate of reaction is very fast. So, it is whenever you have a rate of reaction very fast, which is controlling? Mass transfer controls. So, that is why only mass transfer equation will come for the design of a chemical reactor. It is surprising, So, that is the beauty in heterogeneous systems. Now, let me take one a non catalytic reaction, very simple one. Non catalytic reaction. So, before going to non catalytic reaction, one more word about catalytic reaction. I have taken, when you take step 1 and step 2 and step 3 for catalytic reaction, assuming you have porous particle, first step is mass transfer, second step is reaction, third step is not disruption, mass transfer back through the filling. Disruption means on the surface it comes, all that we club together. So, then I told that for first order we could first order rate we assumed, then it was very easy for us to eliminate unknown concentration, that is CAS. Unknown means I cannot measure that concentration. That is why we could get that very simple expression. I can give in the surprise test, sometime I have to start now that test also. Simply that one equal to kCa square. Mass transfer step is same, kg into CAB minus CAS. Now, that is equivalent to k into CAS square. CAS square. The moment I put that CAS square, then you have a quadratic equation, because our idea is to eliminate CAS. So, you have to solve from this quadratic equation CAS, and then that CAS afterwards you can substitute in any one mass transfer equation or reaction equation. Totally the rate becomes very complicated, but still it will be in terms of k and kg. So, depending on which condition, which is rate controlling, you can simplify that equation also in terms of only kg or in terms of only k. If you have very slow reaction, the fellow is not as I told you, you are not hungry at all, you have eaten sufficiently, then idlis will be continuously coming throughout, and you have the concentration of idlis on that conveyor belt throughout. So, that means throughout the film you have the same concentration, because the rate is not very fast. the particle is not able to convert the molecules that are coming to the surface into products. So, then what happens? The entire surface will be covered by CAB. So, that is why you draw that line, CAB, constant line, what we have drawn in that, right. So, that is the reason why that line, and also it is 0 line, because on the surface, I think Swami or someone was asking me that question, if there is no concentration, how can it react? It is not exactly mathematical equivalent of CB equal to 0. Whatever particles are coming to the surface, they are immediately converted. At any time when I look at the surface, practically there are no, there is no reactant left.
If it is a 0, we are not considering the.
It is not 0 in the mathematical sense, right?
You can say minimum, CA as minimum.
What is minimum? How do I know what is minimum?
No, sir, we are talking about the resistance of the mass transfer step.
Yeah.
We are not talking about,
Okay, you tell me, I think to understand the same thing. My example, all of you are tremendously hungry. You can eat an elephant also if you can see, so much hungry. Okay? Yeah. So, then at that time, this is idlis are continuously coming, right, and you are able to eat. So, then at any time continuously they are coming. So, at any time can you see any idli on the surface?
Idlis are there.
Yeah, they are there.
But after coming to the surface, they are getting 0.
Yeah, this is I have my catalyst particle starting from here, all the people are standing here. Both sides people are standing, right. I may have conveyor belt before into the kitchen. The moment they touch the surface is you standing, waiting to take the, whatever they give. Forget about idlis. Okay. So, then the moment it started coming, first person takes like this, second person long hand takes like this, third person also pushes the second person and then takes. So, what can you see there? You cannot see any concentration of idlis on that left. Similarly, on the surface you have the molecules just coming and then touching the surface, converted to product, and now if you see that what is the concentration of reactant on the surface, practically 0. That is what is the meaning of that. Okay? You are telling that concentration is decreasing like this, then these particles, few particles which are coming to the surface, they are very quickly converted. And the beauty there is, now if you are intelligent, you should be able to supply as much as possible, okay, as much as possible, so that you will get maximum rate. Why? Because the particle is capable of reacting, converting the molecules very quickly. Now, if there is a film, then the resistance will come. If you remove the film, so directly you have lots of A that is coming to the surface where rate of reaction is very high. How do you remove the film? Fluid mechanics will never allow you to remove high flow rate. So, the moment you have high flow rate, film thickness will reduce, then the concentration gradient will not fall that much. Okay? That the concentration on the surface, forget about idli. So, the concentration on the surface practically nil. Devayan?
Sir, because in this case, this idli is moving, it's very much longer. What do you say, with time this idli will come and come and come. So, when that two persons will be standing there, they will be taking it up.
Yes.
If no persons after them are standing there, so there will be idli concentration will be there, right? Because
no, the two people are so hungry, any number of idlis they can eat. What do you mean? I think so hungry, that means the rate of reaction is very, very high. Temperature is 600, 700, 800 degrees centigrade. Okay? So, any molecule coming to the surface will be immediately converted to product, and that is why practically you see that, practically you see that on the surface there is no concentration. Here also idli's example, there may be a piece of idli left somewhere. which is stuck to the conveyor belt and all that. Okay. Yeah. So, like that there may be one or two molecules, but that will not give you any rate of reaction in the sense that significant rate of reaction. That is why if you see my notes, I think I wrote that CAS is almost 0, like this I put and then put 0. And you are really, see, Swami is taking whenever mathematics are required, he won't bother about mathematics, but here mathematics are not required. Okay, CAS is not exactly equal to 0, but it is approximately 0, tends to 0. That means, the moment you have any molecule coming to the surface, it is getting converted to product. So, practically I do not see many molecules of A on the surface. That is what is the meaning of that. Okay? So, that was the example what we have given. So, now non-catalytic reaction, what we take is coal combustion. Again I am simplifying many things. Yeah. So, coal combustion, you can use again, the moment you have coal combustion, what are the various types of reactor used for coal combustion? Because first of all, yeah, excellent, fluidized bed is one. Okay. Anything else?
Moving bed.
Moving bed, who is telling moving bed? Okay, moving bed, yeah. Still, because that has to come to your mind first. When you say coal combustion, okay, what are the possible? Because in chemical engineering, that is the beauty I am telling you. The beauty part in chemical engineering is we do not have a single solution problem. We have many possibilities, right? So, this reaction can be conducted in many ways. For example, coal combustion. Even catalytic reaction can be conducted in many types of reactors, right? But all those reactors will be simplified in ideal reactors wise, either only those two, either mixed flow or plug flow if it is continuous system. If it is batch, anyway batch system. So, any reactor you bring, okay, what about you, can't you use rotary kiln for combustion? We can. What about packed bed?
Yes, we can.
Why we can definitely, why? What is the problem? So, that is what I can put all the coal inside, burn it, but only thing is it is not steady state. We need steady state energy that is coming out of this combustion, but that is not steady state if I take batch, because initially you may have big fire, initially slow fire again, when it catches all the particles catching fire, then it becomes to peak and afterwards it falls. So, that kind of situation I may not require. Okay? So, that is the reason why for continuous flow only we will go. Yeah, only that, or you have any other thing? You have not heard moving grate conveyor